Hello everyone, Assalamualaikum warahmatullahi wabarakatuh. My name is Gina Rafida. I want to explain about motion controller. Motion control is a subfield of automation encompassing the system or subsystems involved in moving parts of machines in controlled manner. Motion control is an industry term used to describe a range of applications that involve movement with a varying degrees of precision. Many motion control applications require only that an object to be moved from one place to another with limited concern for acceleration, deceleration, or speed of motion. On the opposite extreme are machine tool applications which require the precise coordination of all aspects of motion, including a high degree of coordination for multiple simultaneous movement. The main components involved typically include a motion controller, an energy amplifier, and one or more prime movers, or actuators. Common control functions include the first one, velocity control, and the second one, position or point-to-point control. There are several methods for computing a motion trajectory. These are often based on the velocity profiles of a move such as a triangular profile, trapezoidal profile, or an S-curve profile. The third one is pressure or force control. And the fourth one is impedance control. This type control is suitable for environment interaction and object manipulation, such as in robotics. And then electronic gearing or cam profiling. The position of slave axis is mathematically linked to the position of a master axis. A good example of this would be in a system where two rotating drums turn at a given ratio to each other. A more advanced case of electronic gearing is electronic camming. With electronic camming, a slave axis follows a profile that is a function of the master position. This profile needs to be salted, but it must be an animated function.
Now, my name is Dwita. I'm going to explain about the purpose of motion control. The motion control system purpose is to control any one or combination of the following parameters. The first is position, the second is velocity, the third is acceleration, the fourth is torque. Single axis motion involves controlling one rotational axis. This is typically a motor shaft that can be driven forward or reversed. Mechanisms are often used to translate the rotational motion into linear motion. Multi-axis control involves control of multiple rotational axes, each of which could be converted into linear motion. Some applications require the control of multiple axes, with each axis operating independently. Other applications require varying degrees of coordination for multiple axes, ranging from synchronizing the start of motion control for multiple axes to the highly coordinated multiple axis control required for machine tool applications. PMC defined is programmable motion control, defined as the application of programmable hardware and software in conjunction with input sensory device, actuators, and other feedback devices for the control of one or more linear or rotary motion. Expanding on this definition in today's concept for the equipment used to control motion, a programmable motion control commonly takes the form of a microprocessor-based system. The system will be comprised of the following basic elements: control, amplifier, actuator, and feedback. A simplified block diagram of a programmable motion control system appears below.
My name is Anissa and I'm going to explain about motion control loop. Motion control may be open loop or closed loop. In open loop system, the controller sends a command through the amplifier to the prime mover or actuator and doesn't know if the desired motion was actually achieved. Typical system includes stepper motor or fan control. For tighter control with more precision, a measuring device may be added to the system, usually near the end motion. When the measurement is converted to a signal that is sent back to the controller, and the controller compensates for any error, it becomes a closed-loop system. Typically, the position or velocity of machines are controlled using some type of device such as hydraulic pump, linear actuator, or electric motor, generally as servo. Motion control is an important part of robotics and CNC machine tools. However, in this instance, it is more complex than we use, with specialized machines such as kinematics are usually simpler. The latter is often called General Motion Control or GMC. Motion control is widely used in the packaging, printing, textile, semiconductor production, and assembly industry. Motion control encompasses every technology related to the movement of objects. It covers every motion system from micro-sized systems such as silicon-type micro-induction actuators to micro-SIML systems such as a space platform. But these days, the focus of motion control is the special control technology of motion system with electric actuators such as DC or AC servo motor. Control of robotic manipulator is also included in the field of motion control because most of robotic manipulators are driven by electrical servo motors and the key objective is the control of motion.
Now I'm Shiva. I'm going to explain about the basic architecture of a motion control. First, a motion controller to generate set point, the desired output or motion profile, and in closed loop system, close a position or velocity feedback loop. The second is a drive or amplifier to transform the control signal from the motion controller into energy that is presented to the actuators. Newer intelligent drives can close the position and velocity loops internally, resulting in much more accurate control. The third is a prime mover, or actuator such as a hydraulic pump, pneumatic cylinder, linear actuator, or electric motor for output motion. The fourth is, in closed-loop system, one or more feedback sensors such as optical endecores, resolvers, or Hall effect devices to return the position or velocity of the actuators to the motion controller in order to close the position or velocity control loops. The last is mechanical components to transform the motion of the actuator into the desired motion, including gears, shaftings, ball screw, belts, linkages, and linear and rotational bearings. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Tonight we are going to discuss about counter in electronic industry. So before we explain more about it, we'd like to introduce ourselves. We are from group 3. We are consist of 5 persons. Angga Nugraha, Brahmasta Alia, Geni Gemilang Adia Bentang, Muhammad Fadilah, and Yansha Alizan Guzman. Okay, let's start with the definition itself. The counter is electronic circuit used to do a count of a number in sequence which in forward counting or reverse counting by electrical poles. So the image shown there is one of the sample of circuit which has a counter to count the number. The next is we will discuss about the type of the counter. There are two types of counters. The first is synchronous counters, and the second is asynchronous counters. So it operates simultaneously with clock poles. Sometimes it can be called as series counters. So the second one is asynchronous counters. It's the reverse way to synchronous counter. It operates unsimultaneously with clock poles, or can be called as ripple counters. Here are some of utilization of counter. First, we can use it as we can count how much poles insert. Second, we can use as split frequency. The third one is address sorting. And the last is some arithmetic circuit. The application itself, in real life, we can see and sample in the display a car with a safety equipped with a simple anti-theft program. The car is designed in such a way that if the car is robbed and rushed, then in 50 times the wheel rotation of the car will activate the safety system in the form of relay that decides a car engine working system. But before the engine turns off, 10 seconds before activate the flip-flop Y1 buzzer, very simple but deadly. Wheel rotation sensor is represented by X1 and its relay Y0. This anti-theft system will automatically deactivate when X2 detects the electrical energy of the car generated as a sign that the car is alive. Of course, the first enable X3 anti-theft mode. The system will be normal again if the car is in regular mode. So that's the sample of the counter in a real life. So this is a LED sim counter. First we play. We push the play button. Then as you can see, there is a counter, and the preset we set 3. If we push input 0, so the ACC will count it as 1. If you push again, become 2. If we push again, it become 3. So because the ACC is 3, it means equal with preset. The light output 0 and output 1 will turn on, and then as both of them are turned on, it will activate around 3, and it means if we push the input 1, the SCC will read that pulse and make it become 0 again. Because it's been reset to 0 again, so it's not the same. The number is not the same with the preset. So the output of 0 and 1 will be switched off.